Hello people and welcome back to Maybe Smile. In this session we will be doing linear inequations. Now in order to solve linear inequations you should know how to solve linear equations. And then there are two rules which I will be sharing with you to solve linear inequations, and you should also know the types of numbers that you have already studied in your lower grades. We will first go through the types of numbers, then we'll see the two rules, and then we'll dive into the questions. Okay, let's go. So the first type of numbers are basically natural numbers. Okay, now natural numbers are those numbers which we generally use to count anything in daily life. So basically 1, 2, 3, 4, and it keeps on going. The next set of numbers is whole numbers. Now whole numbers is basically all the natural numbers, but 0 is also included in this family. So it is 0, 1, 2, 3, 4, and then it keeps on going. The next one is integers. Now these are interesting ones. Just a moment. Integers. Okay. Now integers are basically all the natural numbers. Then you consider all the natural numbers with a negative sign, and then you also include the 0. So basically if I start from negative infinity, I can have negative 4, negative 3, negative 2, negative 1, 0, and then 1, 2, 3, 4, and it keeps on going. So basically all the numbers that we know which are non-decimal and non-fractional numbers including the 0, these are known as integers. Okay, and then the last thing is real numbers. You need to know what real numbers are. Okay, so the thing is all these things that I've written here are not that important. The real important thing is the notation. Okay, so natural numbers are denoted by capital N, whole numbers are denoted by capital W. Integers are sadly not denoted by I, they are denoted by capital Z, and real numbers are denoted by R. Now I didn't tell you what real numbers are. Real numbers are basically all the numbers that you have actually seen till date. All of them are real numbers. Or if I should say that if you don't know what imaginary numbers are, then all the numbers that you know are real numbers. Okay. Now, the N, W, Z and R that is written over here is generally written in a very fancy font. So yeah, don't confuse with that thing. It is basically trying to say you that this is one type of the number that we have already studied. Okay, now let us move ahead to the rules that we should know to solve this thing. Okay, so let us say that X is greater than Y. So if X is greater than Y, then negative X would be less than negative Y. This means that if I change the sign on both the sides of the inequality flips. If the sign on both the sides has changed, then the inequality should flip. That is the rule. Let us take an example for this thing and we should understand it better. Okay, let's say 10 is greater than 5. Okay, we all know 10 is greater than 5. But what if I change the sign? If I make it negative 10 and if I make it negative 5? Now obviously negative 5, as we all know, is closer to 0. So it is a greater number as compared to negative 10. That is the first rule that we should know. Okay, this is not a very big thing. The real big thing is that if X is greater than Y, then 1 upon X is less than 1 upon Y. Now, why do I say that this is a really important thing? Because this thing turns up in other chapters also. And especially if you are someone who is doing word problems on linear equations, or you're doing word problems on quadratic equations, they could put up questions in front of you that the sum of two numbers is something and the sum of the reciprocals of the difference of the reciprocals. In those cases, you should know when it says difference of the reciprocals, you should know which one is bigger and which one is smaller. Okay, so let us take a similar example for this. So let's say 10 is greater than 2. What if I flip it? If I make it 1 upon 10 and 1 upon 2. Now obviously 1 upon 10 is 0.1 and 1 upon 2 is 0.5. Now as we can see that 0.5 is greater, and obviously 1 upon 2 is greater than 1 upon 10. So basic rules understood with very basic examples. Okay, these are the only two rules that you should remember while solving this entire chapter. Okay, let us dive into the questions. Okay, so the first question which I have over here, it says for the given inequations, graph the solution on the number line. And the first one is negative 4 is less than equal to 3x minus 1 is less than 8. Now we can see there are two inequalities given over here. Whenever we have two inequalities, you split it up into two different inequations and then solve it. Later on, I'll show you how not to do that and like maybe jump through this step and still get your correct answer. Okay, what I would do is I'll write this one first. So it would be negative 4 is less than equal to 3x minus 1, and I will write the other one, which is this part, which is 3x minus 1 is less than 8. So these are two different inequations. I need to solve for x and then combine them again. Okay. So I'll send this negative 1 to the other side change, sign change. So negative 4 plus 1 is less than equal to 3x. Negative 4 plus 1 is negative 3 is less than equal to 3x. And then I can cancel out 3 times 1 and 3 times 1. So negative 1 is less than equal to x. That is one of the solutions. Over here, I can send the 1 to the other side. So 3x is less than 8 plus 1, and 3x would be less than 9. And when I cancel this out, 3 times 1 and 3 times 3, I got x to be less than 3. Now I need to combine these two things. So I can see that there is an x over here, there is an x over here, just fuse them. Okay. So my final answer would be negative 1 less than equal to x less than 3. Okay, that is my final answer. This thing represents that my x is between negative 1 and 3. So it lies between negative 1 and 3. Now it also says that I have to graph the solution on a number line. So what do? I basically make a simple number line over here. On the number line, I should have a 0, then a 1, a 2, and a 3. Maybe I can have a few more numbers, but I'm just not doing it. Negative 1, negative 2, negative 3. Okay, I'll put up an arrow over here, put up an arrow over here. Okay. On the number line, I can see that there are the numbers which I actually need. Okay, fair enough. And then what do? I look at the inequalities. This one says that negative 1 is less than or equal to, which means x can be equal to negative 1. So if it can be equal to negative 1, I put a solid thing over here, a solid circle over here. And then 3, it says that x is less than 3. X is not less than or equal to 3, which means 3 cannot be the value of x. So 3 is not included. So I'll put up a hollow thing over here that's not included, and then I just connect these two circles that I just made. So this is basically all my solutions, like from negative 1 up till 3, negative 1 included, 3 not included. All the numbers that lie between these two numbers are my solutions, could be the value of x, and that is how you do it. Okay, let us move ahead to the next question. This one says the same thing, but we've been given two different equations over here. Okay, let's see what are the two different equations. The first one is x minus 1 is less than 3 minus x, and the second one is over here, which says 3 minus x is less than equal to 5. Okay, let's solve the first one first. All the x's on one side, everything that does not have an x goes to the other side. Okay, so x, that negative x comes to this side and it becomes positive x. So x plus x is less than 3. The negative 1 goes to the other side and becomes a plus 1. X plus x is a 2x is less than 4, and x would be less than 2. That is one of the solutions. Let us come to the other side. Okay. So negative x is less than equal to 5, and the 3 goes to the other side and becomes minus 3. So negative x is less than equal to 2. Now I don't need the value of negative x, I need the value of positive x, which means I can change the sign on both the sides. Okay, fair enough. X, and this becomes negative 2, and if you remember the rule, if I change the sign on both the sides, my inequality has to flip. So this is what my inequality becomes. X is greater than or equal to negative 2. When I combine these two, I can see that it could be written as negative 2 less than equal to x less than 2. So basically x lies between negative 2 and positive 2. Again, the same kind of a number line I'll build. Put up a 0 in between. I'll have a 1, I'll have a 2, I'll have a 3. It can keep on going. Negative 1, negative 2, negative 3. Put up an arrow on both the sides. Okay. Where do I start from? I start from negative 2, and this thing is included because it is negative 2 less than or equal to. So negative 2 will have a solid circle over here, and it goes up till 2. 2 is not included, so a hollow circle over there, and then just join it with a line. That is how you can do it. Or some people also shade all the things between them, but I just don't like doing it. This is a very good solution. Okay, let us move ahead to the third question. Okay, this one says list the elements of the solution set of the inequation, this thing. So which means now we have to list down the elements, and if you see very closely, we have been given that x belongs to n. X belongs to n means x is all the natural numbers. So if it is all the real numbers, or if it does not say anything, I can't list down numbers because there would be infinite amount of numbers. But if it says it is natural numbers, so obviously in a bounded thing, I will have a few set of numbers which I can represent very easily, or I can list them very easily. Okay, let us pick up the two inequations that are given to us. So it is negative 3 is less than x minus 2. So negative 3 is less than x minus 2. That is one of the thing. The second thing is x minus 2 is less than equal to 9 minus 2x. X minus 2 is less than equal to 9 minus 2x. Okay, let's solve this one first. Negative 2 goes to the other side. So negative 3 plus 2 is less than x. Negative 3 plus 2 is a negative 1 is less than x. That is one of the solutions. Let's come to the other side. All the x's on left hand side, everything that does not have an x goes to the other side. Okay, so x plus 2x less than equal to 9 plus 2. 9 plus 2. Okay, x plus 2x is just a 3x is less than equal to 9 plus 2 is 11. So x would be less than 11 over 3. Now 11 over 3, as we all know, is a decimal. Now we need to figure out what 11 over 3 is. You can just basically simplify it and it would be around 3.666 recurring. Okay, so I'll just write it as x is less than equal to 3.666. Okay, when I combine these two, my solution would be negative 1 less than x less than or equal to 3.66, and I can just write 3.6 bar over here. Okay, this is actually the solution for x, but this is not what the question asks. The question says list the elements of the solution set. Now this is the solution set. I need to list down the elements of this solution set. So I have to start from negative 1 and then I have to stop at 3.6, and in between these two, whatever is the possible solution, I should give the solution. Now the question says x belongs to n, which means I need to pick up only natural numbers. So natural numbers are basically the counting numbers which starts from 1, 2, 3, 4 and so on. So negative 1 ignore, 0 ignore, 1 could be my answer, so 1 is my answer, 2 is surely my answer, so I'll write 2. 3 can also be my answer because the range over here is 3.6, so I can also write 3 as my answer. How do I represent it as my answer? Just put it up in a curly braces and write a is equal to, or solution is equal to 1, 2 and 3. These are the elements of the solution set. Okay, let us move ahead to the next question. Now this one says solve this. These are two inequations that are given to us. Why did I pick up this question? Because there are fractions in between them. Okay, let's solve. Again the same pattern. I'll pick up the first inequation, and this is 4x minus 19 is less than 3x over 5 minus 2. And then I'll pick up the second one, which is this thing, and it says 3x, one moment, yeah, it says 3x over 5 minus 2 is less than equal to negative 2 over 5 plus x. And then at the end we'll see what the solutions could be, because here it does not say that we have to represent it on a number line. It just says x belongs to R, which means x is all the real numbers. Okay, so we just have to write the solution like x is bounded by these two numbers. That's it. Okay, let us solve this one. I will keep all the x's on one side, everything that does not have an x to, on the other side. But before doing all of that, I do not like fractions. So I'll first get rid of the fractions. Now to get rid of the fraction, I will multiply the entire thing by 5 so that the 5 from the denominator just goes away. Okay, so this becomes 20x minus 5 nines are 45, 4 carry over, 5 ones are 5, and 95 is less than 3x minus 10. Okay, we'll take all the x's on one side. Everything that does not have an x goes to the other side. So 20x minus 3x is less than 95 minus 10. 20x minus 3x is 17x is less than 85. Okay, now we can simplify this thing. I suppose 85 divided by 17 is just 5, so I can say x is less than 5. That is one of the solutions. Let us come to the second part, and again we have the same problem over here. I need to multiply the entire thing by 5. Okay, so this thing becomes 3x minus 10 is less than equal to negative 2 plus 5x. All the x's on one side, everything that does not have an x goes to the other side. So 3x minus 5x is less than equal to negative 2 plus 10. This is a 5x. Okay, less than equal to. 3x minus 5x is negative 2x, and minus 2 plus 10 is just an 8. I can say negative x would be less than equal to 4 because I divided by 4. Now I don't need a negative x, I need a positive x. So I can write x and I can write negative 4. And if you remember the rule, we need to flip the inequality also whenever we change the sign on both the sides. Now I just need to connect these two. How do I connect it? I write negative 4 is less than equal to x is less than 5. Always remember the smaller number comes to the left side and the larger number comes to the right side. Okay, so negative 4 is the smaller number. I'll have to keep it on the left side. 5 is the larger number. It has to stay on the right hand side. Okay, and this is basically my answer. I don't need to represent it on a number line. I don't need to give up a solution set or anything. This is my answer. That's it. Okay, let's move ahead to another question. This one says solve and graph the solution set of all of these things. Okay, and we have two separate equations given this time, or inequations given this time. Okay, like in the question that we have done till now, it was a combined thing, but in this one there are two separate inequations given. So let us solve them separately and then finally combine them and give an answer. Okay, I'll solve the first one. This says 2x minus 9 is less than equal to 7. The 9 goes to the other side, so side change, sign change. So 2x is less than equal to 7 plus 9. So 2x is less than equal to 16 and x is less than or equal to 8. That is one of my solutions. Let us move ahead to the second one. This says 3x plus 9 is greater than 25. So it becomes 3x is greater than 25 minus 9. 25 minus 9 is a 16. So 3x is greater than 16 and x would be greater than 16 over 3. If it were a 15, it would have become 15 over 3 is 5. So this would be a little bit more than 5. Okay. So x is greater than 5 point something something. And now I don't know what that something something is. You can spend time and calculate that, or maybe use a calculator, but I'm just saying that it is 5 point something. Okay, now we need to combine all of these things. So I know it is 5 point something and I know that it is supposed to be 8. So 5 is on the left side and 8 is on the right side. It says I need to graph the solution, which means I need to draw a number line. So let's draw a number line. Okay, this time since I don't have a negative number, I really don't need to start from a negative side or even start from a 0 because it is like 5. So I'll just probably start from a bigger, or even if we start from 0, it's just fair. So 1, 2, maybe we can take 2 steps, or maybe 1 step is okay. 0, 1, 2, 3, 4. You see, that's the problem. If I start from 0, I won't have any space over here. So I'll start from 4. Okay, 4, 5, 6, 7, 8, maybe 9 and 10. That is fair enough. Okay. Now, my answer, my x is supposed to be from 5 and it is, it should end at this thing. I'll just also write the answer. So 5 point something is less than x is less than equal to 8. So that is my solution, basically solution set. Now 5 point something and 8. Now I don't know what it is, 5 point what. So I just don't know. So I'll just put up a hollow thing over here because it is not included. And then it is supposed to be 8 and 8 is included. So I'll just put up a solid circle over here. Okay. Now the thing is, my question says that x belongs to I, which means x is an integer. So even if it is 5 point something, which I don't know, whatever it is, that does not count because it is not an integer. And any which way it is does not count because it is less than, okay, x is greater than that thing. So it does not count. So what would be my answer? 6 is basically my answer. 7 is my answer and 8 is my answer. So my answer includes 3 full numbers, 6, 7 and 8. That's it. These are my solution. That's it. I don't need to represent the 5 also, but like no need to put up a hollow thing on that thing. Okay. So that is the solution of this question. Okay, let's move ahead to the next one. Same kind of question. Is it exactly the same one? I don't know. 3x plus 9, 25. No, it's a different one. Okay. So I have 3x minus 2 is greater than 19. The minus 2 goes to the other side. So it becomes 3x is greater than 19 plus 2. So 3x is greater than 21 and x is greater than 7. Okay, the next one. 3 minus 2x is greater than equal to negative 7. In this question, I'll show you how to switch the places and still not be bothered about the sign. So here I can see that the x thing, the x term is negative. So I just send it to the other side so that it changes its sign like automatically. Okay, does not bother me. Okay, and the negative 7 also comes to this side. So it becomes positive 7 and greater than equal to 2x. This time I don't need to flip the inequality. It only happens when I multiply the entire thing by minus 1, or basically change the sign of every single term. Here I didn't change the sign of 3, so every single term is not counted. Okay, so 10 is greater than equal to 2x and finally 5 is greater than equal to x. So x is between 5 and x is between 7. That is what people would presume over here, but that is not the truth actually, because if you see over here, this thing says that x is less than 5, and the other one, the first one, says x is less than 7. Okay, so x is less than 5, x is less than 7. I technically cannot combine it and write it in a single thing. Like in the previous one, we have combined it. See, x is less than something, x is greater than something. So if x is less than and greater than something, we can put x in between two ranges. Over here, x is greater than something and x is again greater than something. So I can't put it in like I can't bound it between two numbers. So that is the problem. So how do I represent it? I basically just draw my number line. That's my number line. Okay, fair enough. Where do I start? Maybe start at 3 and then 4, 5, 6, 7, 8, 9, 10, and then it keeps on going. Okay, what is x? X is basically all the real numbers. So now we don't have a big problem because it says real number. Okay, let's see what it is. It says x is greater than equal to 5. Okay, greater than equal to, which means I need a solid thing over here for greater than equal to, which means it is all of these things, everything that is on the right hand side of 5. So x is greater than equal to 5, so everything that is on the right hand side of 5 is included. Okay, that is this answer which I've given. Okay, let us put up a tick on that. We have given the answer. Okay, what is the other thing? The other thing says x is greater than 7. X is greater than 7 means I have to put up a hollow thing over here, and I have to put up a thing like this. Now, what is a common space for both the solutions that I've gotten? So this part is basically the common solution for both the things. Okay, so basically my red arrow is my final answer. The blue thing, so basically between 5 and 7, those numbers would not be included because it is not a common solution for both of the things. Okay, so this part, only this much is my answer. This part is not included in my answer. Okay, this happens only when x moves only towards one side. It does not move to the other side, or it is not bounded by two numbers. Okay, keep that in mind. Let us move ahead to the next question. Now this one says solve this thing where x is positive odd integer. We'll worry about that later. Let us first solve this thing. So x upon 2 plus 5 is less than equal to x upon 3 plus 6. I need to get rid of the denominator as usual. I don't like the denominators. If I multiply by 2, the 2 goes away, 3 stays. If I multiply by 3, the 3 goes away, 2 stays. So what I do is I multiply the entire thing by 6. That would help me. Okay, 2 times 1 is 2, 2 times 3 is 6. So this becomes 3x plus 5 6 are 30 less than equal to, this becomes 2x plus 6 6 are 36. Numbers on one side, variables on the other side. So 3x minus 2x is less than equal to 36 minus 30. 3x minus 2x is just x, less than equal to 36 minus 30 is just a 6. So now I got a solution, and I don't have two inequations, so don't really need to worry about combining them. X is less than 6, or x is less than or equal to 6. But what does the question say? It says x is a positive odd integer. It has to be positive. It has to be an odd integer also. Okay, is 6 positive? Yes, it is positive. Is it odd? No, it's not odd. So I can't take 6. So what is less than 6, which is also odd? It is 5. 4 not included. It's an even number. 3 sure included. 2 not included. 1 can be included. Okay, 0 neither positive nor negative. We don't need it. Then anything beyond 0 on the left hand side should not be included, because the question itself says that I need a positive integer. So basically these are my solutions: 5, 3 and 1. Obviously I'm not going to write it as 5, 3 and 1. I'll be writing it as, let's say, A is my solution, put it up in a curly braces, x is equal to and the answer is 1, 3 and 5, because obviously the smaller number comes to the left side and the larger number comes to the right hand side, and that is my solution. Now we have another question which is exactly like this one, and it says it is a positive even integer. We need to solve the thing and we need to report the answer. I will leave this one for you because I know you people are smart and you can do this thing. Okay, let us move ahead to question number 6. Now I have deliberately put up this question over here because in this question I am going to show you how to not separate the two inequations and still get your answer correct. Okay, so let us pick it up. This is negative 2 2/3 and this is 3 1/3. I need to first get rid of these mixed fractions, convert it into improper fractions. Okay, so it would be negative 3 2s are 6, 6 plus 2 is 8 upon 3 less than equal to x plus 1 upon 3 less than 3 3s are 9 plus 1 is 10 upon 3. Okay, so these are the things which I have. This is all improper fractions. Okay, I need to get rid of that 1 over 3 from the middle. Okay, if I just subtract 1 over 3 from all the things, my answer would be good. Okay, so negative 8 over 3 minus 1 over 3 less than equal to x plus 1 over 3 again minus 1 over 3 less than 10 over 3 and again minus 1 over 3. So if you see over here, I've subtracted 1 over 3 from every single thing. So I haven't done anything wrong. In the middle one, the 1 over 3 and the negative 1 over 3 just goes away. To the left side, negative 8 minus 1 is negative 9 over 3 less than equal to, in the middle thing, I just have an x and I'm really happy about that. 10 minus 1 is a 9 over 3. So negative 9 over 3 is just a negative 3 less than equal to x less than 9 over 3 is just a 3. And you see, without separating the things and being bothered to combine them again, I directly got my answer in the combined form. So x is between negative 3 and it is bounded by negative 3 and 3 basically. Okay, now it does not say that I need to plot a line. If it does say that, I will plot a line. So let's just assume it says that I need to graph it. So just plot a simple line, put up an arrow, in between put a 0, and I have 1 2 3 negative 1, negative 2 and negative 3. Okay, if I see over here very closely, negative 3 is included, 3 is not included. Put up a solid circle over here. At 3 will have a hollow circle because it is not included. Connect them with a line. And why do I connect it with a line and why do I not select a few numbers? Because the question itself says that x belongs to R. Okay, if it says x is an integer, then I have to select the integer values or whole numbers or whatever it says. Okay, here it says R, which means all the numbers, all the real numbers are included in between them. Obviously we'll have only real numbers, no imaginary numbers in real plane. Okay, the next question, it is a similar kind of question, but I'm still going to do it. And it also says that x belongs to n, so I'll have to give my answers also. Okay, so negative 2 as it is less than equal to 1 over 2 minus 2x over 3 less than equal to, this is a mixed fraction and I need to get rid of this. 6 on the 6, 6 plus 5 is 11 over 6. Now I can see there are so many denominators, 2, 3 and 6. I don't like denominators. To get rid of the denominator, I just need to multiply it with the LCM. I know the LCM is 6, so I'll just multiply everything by 6. Okay, so the leftmost thing becomes negative 12 less than equal to, when I multiply half by 6, it becomes 3 minus 3 times 1, 3 times 2. So it's basically like this, 3 times 1 and 3 times 2, but I'm not doing it because that 6 is for everybody. I'll be left with a 2, 2 times 2 is a 4, so it becomes 4x less than equal to, this 6 automatically just goes away and I'm left with an 11 over here. Okay, what do I do now? I see that it's a 3 over there in the middle term. I need to basically isolate my x from the middle term. Okay, and also a side note that this method can only be done like without separating. It can only be done if we have x in the middle thing. If you have x in the leftmost and the rightmost thing, you won't be able to do this because x has to be in the middle thing only. Okay, so I'll subtract 3 from everybody. So negative 12 minus 3 less than equal to 3 minus 4x, again minus 3, and then less than equal to 11, again a negative 3. From the middle one, the 3 and the negative 3 just goes away. Now negative 3, negative 12 just becomes negative 15 less than equal to negative 4x less than equal to 11 minus 3 is just an 8. Okay, what do? I divide everybody by 4. Okay, so that I get rid of the 4 from there. So divide by 4 and divide by 4. So this becomes negative 15 over 4 less than equal to negative x less than equal to 2. Now I don't need a negative x, I need a positive x. So what do? I change the sign of everybody. Yes, I change the sign of everybody. So 15 over 4 x and negative 2. Now since I change the sign of everybody, all my inequalities would just flip. Okay, and obviously I won't write the numbers, the solution like this. I just flip it around and I'll write my answer as negative 2 less than equal to x less than equal to 15 over 4. Okay, now the question says that x belongs to n, which means x is all natural numbers. So from negative 2, we just need to start counting where the natural numbers are. So negative 1 excluded, 0 excluded. My solution set would be starting from 1, then 2, 3, and I think that should be it, because had it been 16 over 4, it would have been 4. 16 over 4 is a 4, so 15 over 4 is slightly less than 4, so we just not accept that thing. So 1, 2 and 3 are my solutions. That's it. Okay, I hope you got how to do this. If not, then just rewind it and watch it again. Okay, let us move ahead to the last question of the day. Now this is a word problem, and I've picked it up from a textbook which is Concise by Selena. And this thing says that find three consecutive largest positive integers such that the sum of 1/3 of first, 1/4 of second, and 1/5 of the third is at most 20. Now you must have heard about this word at most while studying probability. In that it says at most 3, at most 5, and at most something. Okay. Now at most means maximum. It could be like maximum that, but not beyond that, can't be greater than that. Okay, there is another word at least, which means it has to be this much. It can be greater than this also. Okay, so here we are discussing about at most 20. Okay, so something is going to be at most 20, like maximum 20, not more than 20. Let's see what that something is. Okay, so now the question says find three consecutive largest positive integers. So okay, it's talking about three consecutive positive integers. I will say let the three numbers, those are the three integers, be x. Now since it is a consecutive thing, the next one would be x plus 1 and the next one would be x plus 2. Okay, what does it say? It says 1/3 of the first. Okay, fair enough. Oh, before that it says sum. Okay, so I need to add up. Okay, I need to add up. Surely, what do I need to add up? 1/3 of the first. Okay, 1/3 of the first. So x over 3. 1/4 of the second. Okay, so x plus 1 upon 4. And 1/5 of the third. So the third number is x plus 2 upon 5, and that is at most 20, which means it could be 20 or less than that, but not more than 20. So I have to put up less than equal to 20. That is the inequality which I just formed over here. Okay, so 1/3 of the first number, which means x over 3, 1/4 of the second number, which means x plus 1 over 4, and 1/5 of the third number, which means x plus 2 over 5, has to be less than equal to 20. Now I obviously don't like the denominators. I'll multiply it with the LCM. 3 times 4 is 12, 12 times 5 is 60, so I multiplied by 60. Now this thing becomes 20x plus 4 into 15 is 60, and then x plus 1 plus 5 times 12 is 60, and then x plus 2 less than equal to 20 times 60 is 1200. So this is 20x plus 15x plus a 15 plus 12x plus 24 is less than equal to 1200. Okay, 20x plus 15x is 35x, 35x plus 12x is a 47x, and I also have a 15 and a 24 over here, so they add up to 39 and less than equal to 1200. I put up an extra 0, sorry. Okay, the 39 goes to the other side, so 47x is less than equal to, I don't know what that thing is. Let me just do it on my calculator. So it is 1200 minus 39. So it would be 1161. 1161. So x is less than equal to 1161 over 47. Okay. 1161 over 47 is 24 point something. Okay. Oh, I don't have space over here. That's so bad. Just give me a moment. Let me shift all of these to the side. Okay. This can come over here. Okay. Yeah. So from here, I can say that x is less than or equal to 24.7. Now, since it is an integer, because the question says positive integers, so I'll have to take an integer which is less than 24.7, and it also says that the largest positive integer. So there are tons of integers which are less than 24.7, but I have to take the largest one. Okay, so I'll say that x is supposed to be equal to 24. So that is my answer, 24. That's my first number. The second number would be x plus 1. Third number would be x plus 2. So my final answer would be 24, 25 and 26. So these are basically my numbers. Okay, and I think that should be it for this session, and I hope all of you understood this thing. Do let me know in the comments if you have any other doubts, or if you know any, if you want to study any other chapter or any specific unit. I will try my best to make videos on that thing, and yeah, that is it. Thank you so much.